Hey friends, how is it going? We are students from the School of Biomedical Engineering of UTM, and today we are presenting to you a topic from the subject of our course. The topic that we are presenting to you today is phase shift keying demodulator. Before we begin, let me introduce to you who we really are. First up, we have the leader of group aka the Alpha, Biragathis Babu. Next up, we have the backbone of the group aka the researchers, Mathiventtan and Ahmad. Last but not least, we have the editors of the group, Tham Chun Hwa and Najib Abdul Salam. Now that you know who we are, without further ado, let's take a deep dive into the topic of phase shift keying demodulator.
So, what is phase shift keying? PSK is a digital modulation technique in which the phase of the carrier signal is changed by varying the signal and cosine inputs at the particle time. What it used for? It used widely for wireless LAN biometric contactless operation along with RFID. Types of PSK. The first one is binary phase shift keying. The second one is quadrate phase shift keying. Binary phase shift keying PSK. It is two-phase PSK. Sine wave carrier takes 0 and 180 degree suppressed carrier modulation. Quadrature phase shift keying QPSK. Sine wave carrier takes 4 phases. These techniques are further extended. It can be done by 8 or 16 value stacks. It also double-side bandpass suppressed carrier modulation scheme. It converts signal in 2-bit pairs. So, what is phase shift keying demodulator? A demodulator is an electronic circuit that is used to recover the information contained from the modulated carrier wave. Binary phase shift keying signals demodulator. It consists of a mixer with local oscillator circuit, a bandpass filter, 2 input detector circuit. By recovering the band limit message signal with the help of a mixer circuit and the bandpass filter, the first stage of demodulation gets completed. In the next stage of demodulation, the bit clock rate is needed at the detector circuit to produce the original binary message signal. Binary phase shift keying signals can be demodulated via multiplication followed by multiplier and integrator. These two components will produce a signal that corresponds to the original binary state. QPSK demodulator. The QPSK demodulator uses 2 product demodulator circuit with local oscillator, 2 bandpass filter, 2 integrated circuit, and 2-bit parallel to serial converter.
So, what is the advantages and disadvantages of PSK? Let's explore together. First, PSK allow information to be carried with the radio communication signal. Hence, it is more power-efficient modulation technique compared with FSK and ASK. It also less susceptible to errors compared to ASK modulation and occupies same bandwidth as ASK. Next, higher data rate of transmission can be achieved using high level of PSK modulation such as QPSK. QPSK is another form of data transport where 4 phase states are used, all within 90 degrees of one another. By using this, the high transmission data rate can be attained with the help of high-level PSK modulations like QPSK, 16 QAM. Here QPSK signifies 2 bits for each constellation and 16 QAM signifies 2 bits for each constellation. It is a non-coherent reference signal. The binary data is decoded by estimation of phase states of the signal. These detection and recovery algorithms are very complex. It is also one form of FSK and hence it also offers lower bandwidth efficiency compared to ASK modulation type. Rapid amplitude change between symbols due to phase discontinuity of PSK. Multi-level PSK modulation schemes, QPSK, 16 QAM etc. are more sensitive to phase variations. So,
So today now we're going to see demodulating phase from a modulator signal and how the small introduction about the demodulating phase in from the modulator signal. Okay, this equation shown in the slide is actually this forming an analytic signal by applying through Hilbert transform and then extracting the instant phase by using. Okay, now we're gonna see what are the application from this phase shift key demodulating, and this is how this theorem is worked in current application, where these are the application used in PSK, where local oscillator, multi-channel VDM, biometric wireless LAN, and delay and added demodulator, nonlinear effects are used in current application in industries and okay, this is the one of the application. The name is local oscillator, where you can use in a super heterodyte receiver, where most of the common radio receiver in worldwide. Okay, now another application of phase shift keying is RFID standard, where use the standard name is ISO 1443. It used in credit cards and biometric passports, hotel room keys, and many other pay wave systems. Now we're going to see how wireless communication can be connected to many devices, and we can use this internet platform to serve many things. This is where the phase shift comes. Okay, this Bluetooth 2 where is displayed at pi 4 with DQ PSK at the slower rate where 2 megabits and 8 double phase shift keying at its higher rate 3 megabits. These two are linked together. Okay, these radio signals are transferred to Bluetooth device and the signal received by smartphones, and the signal is approved by the ID number in the smartphone device, and the smart device transfers the unique number to cloud servers where it can check the actions that they assign. Okay, these were the now Bluetooth device where Bluetooth headphones and Bluetooth wireless keyboard are used to transmit the data in the laptop.
Let us now look at the examples of phase shift keying demodulator. The first example is a phase shift keying homodyne receiver. As you can see here, the input signal, which is a signal light, is passed through a photodetector. Then we have some other components such as low pass filter, decision circuit, local oscillator, loop filter, and the data is then being produced. In an ideal phase shift keying homodyne receiver, as shown, the signal light and local oscillator have identical optical frequency and phase. If the resulting baseband information signal is positive, then a 1 has been received. If the baseband information signal is negative, then a 0 bit has been received. This scheme has the highest theoretical sensitivity but requires an optical phase lock loops and is also highly sensitive to phase noise. Example shown here is a phase shift keying synchronous heterodyne receiver. As you can see here, the signal light is the input which is passed through the local oscillator. Then we have some other common demodulator components such as photodetector, band pass filter, reference oscillator, low pass filter, and also decision circuit. In this demodulator, the intermediate frequency signal is filtered by a band pass filter multiplied by a phase locked reference oscillator to move the signal to baseband, then low pass filtered and sent to a decision circuit that decides if the received bit is a 0 or 1. The receiver requires synchronization of the reference oscillator with the IF signal. This is not easy to achieve in practice because of the large amount of semiconductor laser phase noise.
That is all for our video. We hope that the video has somehow given you an insight to what phase shift keying demodulator actually is. Don't forget to smash that like button and feel free to throw in some comments down in the comments section below. Signing off for now. We'll see you guys in the next video. Cheerio.